Hello everyone, this is Aditya and today we'll study Lambert W function. But before that, please do like, share and subscribe my video and let's dive into the concept. So what is Lambert W function? We will study it using a question also and conceptually too. And I hope that you all know what is an inverse function, right? You should know that what is an inverse function and what are the properties which are required for a function to yield its inverse value, right? It should be bijective, right? You all know it. I am assuming it, right? And if you don't know, it don't matter much because we don't need to dive much into it, right? So let's see. For example, assume a function fx is equal to e raised to the power x, right? And say it is equal to y, right? Okay. So what is the use of this function? We were talking about Lambert W function, and suddenly I am going to the exponential function. Wait, we will see. Okay. So what is its domain? Well, let's see. The domain is from negative infinity to infinity, right? Obviously closed, obviously open braces, sorry, right? And what is the range? And range is from 0 to infinity, right? Okay, it makes sense. Yeah. Okay, so what is the point of discussing this thing on this question? Let's see. And suppose you have to find its inverse value. How you find it? Okay, you say that if e raised to the power x is equal to y, then it implies that ln of y is equal to x, right? Which means that ln y is the inverse of e raised to the power x, right? We say it. So what is its domain? So the domain in this case is from 0 to infinity and the range is negative infinity to infinity, right? Is it the case? Yeah. So what is the concept over here? That when you interchange a function, means you find the inverse, then the domain of the function of the original function becomes the range of the inverse function, and the range becomes the domain of the inverse function, right? That is the basic concept, right? So why I'm telling all this? Wait, just a minute. Let me erase this stuff and we'll come back. So let's see. What does Lambert or Lambert W function state? It states that suppose if you are having a function fx is equal to x into e raised to the power x, right? This is the function, okay? Okay. So suppose you have to find the value of x and suppose it is equal to y and you are set to solve for x. So how you will solve? Well, so there is a function which you can use. We sometimes refer it as product log and somewhat like that, right? So x e raised to the power x is equal to y, and what is its domain? Let's see. Well, domain, we don't care about the complete domain. We will just be worried about the domain in which we can say that the function is 1 1, right? Because for the function to become an because for the case of inverse function, we need that function to be bijective, right? So to make this function bijective, you have to choose a domain such that it is 1 1 and onto, right? Okay, means bijective. So it was calculated at in the domain -1 to infinity. It was 1 1, right? And the range was, you can calculate it, -1 upon e to infinity, right? Okay, it makes sense. Yeah. So if you apply w of x e to the power x is equal to w of y is equal to x, and what is this w? W is called the Lambert W function, right? And what it is doing, it is simply doing the inverse, right, of this expression. And you know f inverse of x is equal to x, right? You all know it. So Lambert W function is the inverse of this function, right? X into e raised to the power x, right? This is your original function, and Lambert W function is the inverse of this function, right? So now you understood that why I was talking about all that stuff. So what is its domain? Well, let's see. The domain of Lambert W function, the domain becomes the range and the range becomes the domain. So the domain is -1 upon e to infinity, right? And the range is the domain of the original function. It is -1 to infinity, right? It is correct. Yeah. So having said all this, we will come back to our problem and let's tackle it, right? Okay. Let me erase it. Okay, so let's see the problem now. You're given 2 raised to the power x plus x is equal to 5, right? You are given this. Okay. So now the question arises that we can't apply hit and trial method also. So if you substitute 1 as a hit and trial, you get 3 as the, for example, fx is equal to 2 raised to the power x plus x. F at 1 is equal to 3, f at 2 is equal to 6. It means that x lies between 1 and 2. We can say this, right? Since it is an increasing function, right? Okay. Okay. Okay, so let's erase this, and 2 raised to the power x plus x is equal to 5. Okay, so let's solve it. Is equal to 5 minus x, right? Okay, divide both sides by 2 raised to the power x, because we have to make it in the form of x into a raised to the power x, right? We have to bring it in this form, right? Okay, so 1 is equal to 5 minus x by 2 raised to the power x, right? Okay, so 1 is equal to 5 minus x raised to the power into 2 raised to the power negative x, right? So this and this are pretty much similar until you multiply by 2 raised to the power 5, right? Then they will become exactly same, right? So let's do it. What's the problem in doing that? So 2 raised to the power 5 is equal to 2 raised to the power 5 into 5 minus x into 2 raised to the power negative x, and you can just add the powers. What do I mean is equal to 2 raised to the power a plus b, right? You all know this property, okay? What is 2 raised to the power 5? It is 32. Is equal to 2 raised to the power 5 minus x into 5 minus x. Or it will be better to say 5 minus x, 2 raised to the power 5 minus x. Okay, everything is good, but you see a 2 over here. Okay, you might be having confusion that it is x and I am getting 5 minus x. Don't worry. Just assume for the time being 5 minus x as t, right? 32 is equal to t into 2 raised to the power t, right? Okay, they are pretty much similar, but there's a 2. So how do we remove it? Well, just apply simple property. 32 is equal to t or t into a raised to the power ln of 2 raised to the power t, right? What I've done is e raised to the power ln x is equal to x. You know this property, right? Okay. What you, if you have to prove it, you can take both sides ln and you get ln x, which means ln x of ln e is equal to ln x, which means ln x is equal to ln x, right? You know it. Okay. So I did not need to discuss it, but for purpose of making things clear, I discussed. Okay. So 32 is equal to t into this quantity, right? So you can bring t outside. What I mean is t out of this ln, right? So you get t of ln2, right? Okay. Now one more thing. Now you can do is that t of ln2 as y, right? Just substitute it, right? No need to worry. So what is t? T is equal to y upon ln2, right? It makes sense? Yeah. So 32 is equal to y by ln2 e raised to the power y, right? Is it correct? Yeah. So y e raised to the power y is equal to 32 ln2, right? Okay. And to a great surprise, it is the Lambert W function, right? Means it is the inverse of Lambert W function, and we need to take the Lambert function, right? Oh yeah. So if you take Lambert W function of y e raised to the power y is equal to Lambert of 32 ln2, you end up getting it will be what? It will be simply y, right? You know w of x e raised to the power x is equal to x, right? I told you before. If you had watched the video, please carefully, right? Okay, so that is the thing. Okay, and you get w of 32 ln2, right? Okay, what is y? Y is T ln2 is equal to Lombard W of 32 ln2, right? Okay. And what was T? T was 5 minus x, right? ln2 is equal to W of 32 ln2, right? And you solve, you get x is equal to Lombard of 32 ln2 by ln2, right? And it will be 5 minus this quantity, right? Just see if I made any mistake. If it is correct, then it's fine. If it's not correct, then please comment me in the section. Please comment right, and I will see to it, right? But I think it's correct. Okay, so this, yeah, it is correct. Okay, and you solve, you end up getting 1.716, right? You can calculate on any scientific calculator or maybe from any website. It will be this value. It is a well-known result, right? Okay, so I hope you all understood how to use the Lambert W function and what are its uses, because many a times we study the functions but we don't come across its uses and somewhat like that. Okay, but I hope you all understood it, and if you all enjoyed the video, then please do like, share and subscribe, and thanks a lot for watching it. Bye bye, take care.